Hi, Namaste. My name is K. Harshavardhan Reddy, studying 10th class at ZPHS Saroornagar. With the inspiration of video classes from TSAT, today I am going to explain you about 10th class Mathematics chapter number 4, Pair of linear equations in two variables. Before going to this chapter, we must have the knowledge of algebra for easy understanding and solving the problems of this chapter. First, we will discuss about a linear equation. What is a linear equation? It is an algebraic expression or equation in which the maximum degree is 1 or the degree of the equation is 1. If we draw the linear equation on a graph, we get a straight line. For example, y equal to mx plus b. That means an algebraic equation in which each term has exponent of power less than or equal to 1 and the graphing of the equation results in a straight line. Next, we will discuss about two variables. What is a linear equation in two variable? An equation of the form ax plus by plus c equal to 0 where a, b, c are real numbers and a square plus b square is not equal to 0 is called a linear equation in two variables where x, y are variables here. Now we will go to the solutions. A pair of the values of the variables x and y which together satisfy each one of the equation is called a solution for a pair of linear equations. Now methods of finding solutions for the pair of linear equations in two variables. There are two methods for finding solutions. Methods for finding solutions of linear equations of two variables are two types. One is graphical method, that means finding solution with the help of graph, and another is algebraic method, that is with the help of using algebraic expressions like substitution and elimination. Now we will discuss about the graphical method. When a1x plus b1y plus c1 is equal to 0, where a1 square plus b1 square is not equal to 0 and a2x plus b2y plus c2 equal to 0 and a2 square plus b2 square is not equal to 0, form a pair of linear equations in two variables. If the graph of the linear equation in two variables is a straight line, the ordered pairs of real numbers x, y representing points on the line are solutions of the equation, and ordered pairs of real numbers x, y that do not represent points on the line are not solutions. When a pair of linear equations are drawn in the same plane, then three situations are possible. Situation 1 or case 1. The two lines intersect at each other. Here a1 by a2 is not equal to b1 by b2 and the pair of linear equations are consistent. Situation 2 or case 2. When the two lines are parallel. Here a1 by a2 is equal to b1 by b2 but not equal to c1 by c2 and the pair of linear equations are inconsistent. Case 3. When the two lines are coincident. Here a1 by a2 is equal to b1 by b2 is equal to c1 by c2 and the pair of linear equations are consistent and dependent. Now we will discuss an example problem by the graphical method. Solve the equations graphically. X plus 3y equal to 6 and 2x minus 3y equal to 12. For the equation x plus 3y equal to 6, by taking the values of x as 0, 2, 4, 6. By substituting the values of x in the equation, we get the values of y as 2, 4 by 3, 2 by 3 and 0. Together we get the values of the ordered pair x, y. And for the equation 2x minus 3y, by taking the values of x as 0, 2, 4 and 6, and by substituting we get the values of y. Together we get the values of the ordered pair x, y. By plotting the points on the graph, we get the graph as shown in the figure. Both the lines meet at the point 6, 0. Therefore, the solution for the pair of linear equations of two variables is 6, 0. Friends, I hope you understood the graphical method. Now we are going to the algebraic method. In algebraic method, we have two types: substitution and elimination. For substitution, step 1. First, solve one linear equation for y in terms of x. Step 2. Then substitute that expression for y in the other linear equation. In the other linear equation, you will get an equation in x. Step 3. Solve this and you have the x coordinate of the intersection. Step 4. Then plug in x to either equation to find the corresponding y coordinate. Now an example: solve the equations by substitution. X plus 3y equal to 6 and 2x minus 3y equal to 12. Now solution. According to step 1, we have to prepare an expression for y in terms of x. So y equal to 2 minus x by 3. By substituting in second equation, that is 2x minus 3y equal to 12, we get 2x minus 3 into 2 minus x by 3 equal to 12. That is, by simplifying, we get 2x minus 6 plus x equal to 12. Again simplifying, we get 3x equal to 18. Then by dividing by 3 on both sides, we get x equal to 6. By substituting the value of x in any of the equation, we get the value of y, that is 0. So the solution of the given pair of linear equations is 6, 0. Now the second way of finding solutions in algebraic method is the process of elimination. Step 1 in elimination process is multiply each equation by a suitable number so that the two equations have the same leading coefficient. Step 2. Subtract the second equation from the first. Step 3. Solve this new equation for y. Step 4. Substitute y into either equations and find the value of x. Now an example problem. Question: solve the equations by elimination method. X plus 3y equal to 6 and 2x minus 3y equal to 12. Here x plus 3y equal to 6 and 2x minus 3y equal to 12 have the coefficient of y as 3. So step 1, we need to multiply equation 1 and equation 2 with a suitable number to get a leading coefficient. But in the given problem, we have the coefficient of y as 3 only. So we multiply both the equation 1 and 2 with 1. Now step 2, add or subtract the equations. So by adding both the equations, we get 3x equal to 18. And by step 3, by simplifying the equation for x, we get x equal to 6. And by step 4, substituting the value of x in equation 1 or 2, we get the value of y of the y coordinate as 0. So the solution for the pair of linear equations is 6, 0.
I hope you like my explanation. If you like, please like and share my video, and if you have any doubts, please mention it in the comment section, and don't forget to subscribe my channel. Thank you. Namaste.